Okay, let's try to answer question number 21. Which statement about elements in group 1 and group 7 of the periodic table is correct? Group 1 and group 7. So for group 1, the elements consist of lithium, sodium, potassium, rubidium, and etc. While group 7 is halogen, it consists of fluorine, chlorine, bromine, and iodine. Let's see one by one. Bromine reacts with potassium chloride to produce chlorine. So let's see. Bromine reacts with potassium chloride to produce chlorine. Okay, for group 7 or halogens, as go down the group, the reactivity becomes less. So it's less reactive as go down the group. So in this case, bromine cannot displace chlorine in the solution. So there will be no reaction. So remember, the top element can displace the bottom element because the top element is more reactive than the bottom element. As go down the group, they have less reactivity. In this case, bromine is less reactive than chlorine, so bromine cannot displace chloride ion. Okay, next. Iodine is monoatomic nonmetal. No, it's not correct. All halogens are diatomic molecules, so it exists as diatomic molecules, so F2, Cl2, Br2, and I2, not monoatomic. Next, lithium has a higher melting point than potassium. For group 1 elements, as go down the group, can you guess how is the melting point? The melting point decreases because the metallic bond is getting weaker. So it's easier to break the metallic bonds as go down the group. Less energy is required to break the bonds. That's why the melting point decreases as go down the group. So lithium has a higher melting point than potassium. Yes, it's correct. Lithium has a higher melting point than potassium. Okay, so it's correct. How about D? Sodium is more reactive with water than potassium. As go down the group, the reactivity becomes more. For group 1 and group 7, they have opposite reactivity. So for group 7, as go down the group, they have less reactivity. So they are less reactive, while for group 1, as go down the group, they have more reactivity. So more reactive as go down the group. So it's wrong. Sodium is more reactive with water than potassium. No, it's not correct. Potassium is more reactive with water than sodium. Okay, so the answer is C. Next, 22. Which statement about elements in group 8 of the periodic table is correct? Group 8 is noble gas. Noble gases, the most stable elements. The most stable elements. Why? Because it has full electron configuration or full valence electron or full outermost electrons. Okay, so all of them have 8 valence electrons except helium. Helium only has two valence electrons. Okay, so the answer is A. They all have a full outer shell of electrons. Okay, how about B? They all react with group 1 elements to form ionic compounds. No, they don't form any bonds. Noble gases do not form any bonds because it has been stable, it's already stable. They are all diatomic molecules. No, they exist as monoatomic molecules because, as I told you before, they don't form any bonds. Okay, so they exist as monoatomic. They are all liquids at room temperature. No, they are gases. Okay. 23. Which statement correctly describes X and Y? Okay, it's really clear. X is pure metal while Y is alloy. Mixture of metals. So other metals are added. Okay. So alloy is a mixture of metals or mixture of metal with non-metal. Okay, so the answer is B. X is a pure metal and Y is an alloy. 24. Three metal compounds P, Q, and R are heated using a Bunsen burner. The results are shown. P colorless gas produces which relights a glowing spleen. When compound P is heated, colorless gas is produced which relights a glowing spleen. So this is oxygen. Oxygen gas is produced and the presence of oxygen gas is tested using a glowing spleen and it relights the glowing spleen. How about Q, colorless gas produced which turns lime water milky? So this is carbon dioxide gas. When it reacts with lime water, calcium hydroxide, calcium carbonate is produced. So it makes the lime water turns milky. Okay. And R, no reaction. No reaction for R when R is heated using a Bunsen burner. Okay, let's see. Which row shows the identity of P, Q, and R? Okay, let's see. So, potassium nitrate. Okay, potassium nitrate. When potassium nitrate is heated, there is oxygen gas produced, right? Okay, it's the same as it's similar to group 2 nitrate, for example, magnesium nitrate. When magnesium nitrate is heated, magnesium oxide, nitrogen dioxide, and oxygen are produced. Okay, they have similar reactions, so oxygen gas is produced and this gas relights a glowing spleen. Okay, how about magnesium carbonate? When magnesium carbonate is heated, magnesium oxide and carbon dioxide are produced. When, when carbon dioxide is reacted with lime water, calcium hydroxide, calcium carbonate is produced. It turns the lime water milky. Okay. And R is potassium carbonate. Potassium carbonate cannot be decomposed by Bunsen burner because potassium carbonate is very strong on heating, so it has very high melting point. So if we only use Bunsen burner to heat potassium carbonate, the potassium carbonate will not be able to decompose. Okay, so the answer is C. Okay, next. Which substance is reduced in reactions 1 and 2? Okay, reduce. So we can identify species that gets reduced by using oxygen atom. So look at this one, reaction 1, from zinc sulfide into zinc oxide. Okay, from zinc sulfide into zinc sulfide. From zinc sulfide, I mean from zinc sulfide into zinc oxide. In this case, zinc sulfide is oxidized because it's gaining oxygen, right? So zinc sulfide is oxidized while oxygen is reduced. Why? Because in this case, oxygen gives oxygen atom to zinc sulfide. So now zinc oxide is produced. So oxygen itself is reduced. Okay. How about reaction 2? Zinc oxide into zinc. Okay. It's losing oxygen, right? So zinc oxide is reduced while carbon into carbon dioxide is gaining oxygen, so carbon is oxidized in this case. Okay, which substance is reduced in reactions 1 and 2? The answer is B. Oxygen from reaction 1 and zinc oxide from reaction 2. Okay, 26. So this is about reactivity series. When magnesium is reacted with M nitrate, there is a reaction. When zinc is reacted with magnesium nitrate, there is no reaction. Okay, so that's the way you read the table. What is the order of reactivity of these four metals starting with the most reactive? Okay, I want to make a reactivity series from top to bottom. So let's see one by one. In this case, magnesium can react with all substances. Magnesium can displace Am, copper, and zinc from the solution. So we can say that magnesium is the most reactive metal. So magnesium is toppest, okay? While zinc cannot displace magnesium. So of course zinc is below magnesium. But zinc can displace Am and copper. So I can put M below zinc here. Okay, let's see what's next. M cannot displace magnesium. Yeah, of course, because M is less reactive than magnesium. M is below magnesium. M can displace copper. So I can put copper here below M. M cannot displace zinc. Okay, so it's correct. M is below zinc. M is under zinc, so M is less reactive than zinc. M cannot displace zinc. Okay, copper cannot displace all metals. It means that copper is the least reactive metal. Okay, so as go down, they have less reactivity. Okay, what is the order of reactivity of these four metals starting with the most reactive? The most reactive metal is magnesium, and then zinc, and then M, and then copper. So the answer is D. Next. Why is aluminum used to make containers for storing food? It's really clear because it's resistant to corrosion. Okay. The oxide of aluminum oxide, the oxide of aluminum, okay, I mean the oxide of aluminum oxide prevent the reaction between aluminum oxide and other substance. Okay, so it's called oxide protective layer. Okay, that's why aluminum is unreactive and it's resistant to corrosion. Next, water can be treated by filtration then chlorination, which uses do not need water of this quality is also clear. So the answer is B. 1 and 2 only, which uses do not need water of this quality. 1 and 2. While if we want to drink water, if we want to drink the water must be chlorinated first. Okay. So what is the function of chlorination? To kill the bacteria or microorganism. Okay. Next. Oxides of nitrogen are formed in car engines and are a source of air pollution. To decrease this pollution, catalytic converters are fed to car exhaust. What happens to the oxides of nitrogen in the catalytic converter? Okay, oxides of nitrogen, for example, nitrogen monoxide. Okay, this is the oxide of nitrogen. When the oxide of nitrogen is in the catalytic converter, it's converted into nitrogen. Nitrogen gas is less harmful. Okay. So in this case, nitrogen monoxide is reduced into nitrogen. So the answer is reduction because it's losing oxygen, right? Nitrogen is less harmful. Okay, 30. It's about rusting. What happens to the water level in tubes P and Q? The painted iron cannot rust. Okay. So the iron is painted. So uh, the the paint avoid water and oxygen to react with iron. So iron will not rust. Okay, next. How about P? Iron is not treated at all. Okay, so in this case, water and oxygen from air can rust the iron. So the level of water will rise to react with iron and rust is produced. Okay, so the answer is D. What happens to the water level in tubes P and Q? For tube P, the level of water rises because the water and oxygen from air will react with iron to form a rust, while for Q, the painted iron cannot rust, so the level of water will not rise. Okay, the answer is D. Next, 31. Ammonia is manufactured by the Haber process. The forward reaction is exothermic. Which conditions maximize the yield of ammonia? Oh, sorry. So, to maximize the yield of ammonia, the equilibrium must shift to the right. Remember, this is reversible reaction. The reversible reaction can reach equilibrium. Okay, so we have to change the equilibrium shift to maximize the yield of ammonia. To increase or to maximize the yield of ammonia, the equilibrium must shift to the right. So more ammonia will be produced, more product will be produced. Okay, to shift the equilibrium to the right, the pressure must be increased or decreased. Can you guess? The pressure must be increased. When the pressure is increased, the equilibrium shifts to the side that has fewer gas molecules. In this case, right side or product has fewer gas molecules. 4, 2. Just look at the reaction coefficient of gas, okay? So we see that product has fewer gas molecules. So the pressure must be increased. So the equilibrium shifts to the fewer gas molecules, in this case, right side, and the yield of ammonia will be maximized. How about the temperature? The forward reaction is exothermic. To shift the equilibrium to the right, the temperature must be decreased since the forward reaction is exothermic. So the answer is B. The pressure must be high and the temperature must be low. 32. Which row describes processes X, Y, and Z? Okay, let's see. X, Y, and Z. Okay, let's see process X first. Atmospheric carbon dioxide. So the carbon dioxide from the atmosphere is caused by green plants. Okay, so the carbon dioxide from the atmosphere is obtained by the plants for photosynthesis. Photosynthesis, right? Okay. How about Y? That organic matter is decomposed into carbon dioxide. So what is that? What is that? Can you guess? So that organic matter is decomposed into carbon dioxide. It's combustion, right? So when that organic matter is combusted or burned, carbon dioxide is produced. So this is combustion. While, how about process Z? The animals release carbon dioxide into the atmosphere. This is called respiration. energy is also released. So the answer is C. Photosynthesis, combustion, and respiration. Next, 33. So it's about contact process. The optimum temperature must be about 450 Celsius degree. Okay, before we continue, what is contact process? The production of sulfuric acid. So the optimum temperature must be about 450 degrees Celsius, and the pressure must be 280 m. Okay, it's about 1 to 280 m, and the catalyst used is Fe2O5, vanadium 5 oxide, or vanadium pentoxide. Okay, in this case we don't need to use high pressure because okay, once again, in this case we don't need to use high pressure, very high pressure, because sulfur dioxide can react with oxygen in the low pressure, at, at the low pressure, so at atmospheric pressure. Okay, so atmospheric pressure is about 1 to 280 m, is enough to make sulfur dioxide and oxygen react each other. So the answer is C. Okay, 34. So limestone is heated. The product is calcium oxide. Okay. Limestone is calcium carbonate. The molecular or chemical formula of limestone is calcium carbonate. When calcium carbonate is heated, calcium oxide and carbon dioxide are produced. 35. Which fuel could be gasoline? Is it obtained from petroleum? Yes, of course. Is it used as fuel for cars? Yes. So the answer is A. 36. Why is ethanol a member of the homologous series of alcohols but propane is not? Ethanol, I want to draw the structural formula of ethanol first. CH3, CH2OH, ethanol, alcohol with two carbon atoms. Remember the functional group of alcohol is hydroxyl, OH. Propane, this is an alkane, alkane with three carbon atoms. It's the simplest hydrocarbon. Why is ethanol a member of the homologous series of alcohols but propane is not? Okay, the answer is D. Ethanol contains the same functional group as other alcohols but propane doesn't. Alcohols have the same functional group, OH, or hydroxyl group. Propane doesn't have OH functional group. So ethanol and propane are not homologous series. 37. Chlorine reacts with methane. This is substitution reaction. CH3Cl and HCl are produced. Which statement are correct? The reaction takes place in the dark. No, it's not correct because UV light is required. The reaction of chlorine with methane forms chloromethane. Yeah, this is substitution reaction. One hydrogen atom from methane is removed and replaced by one chlorine from Cl2, and hydrogen atom that's removed combine with other chlorine atom to form HCl. So statement 2 is correct. Chloromethane reacts with chlorine to produce dichloromethane. Yeah, it can be. So next, the reaction of chlorine with methane is an addition reaction. This is wrong. Why? The reaction of chlorine with methane is substitution reaction. So the answer is 2 and 3, C. 38. Which statements about aqueous ethanoic acid are correct? Ethanoic acid is a weak acid. Remember, all carboxylic acids are weak acids. Ethanoic acid contains the functional group COH. Yes, this is carboxyl group. Ethanoic acid reacts with carbonates to produce hydrogen. It's wrong. Okay, let's see. Ethanoic acid reacts with carbonate. Let's use calcium carbonate for example. So CH3COO2 calcium, CH3CO2Ca, calcium ethanoate, water, and carbon dioxide are produced. So this one. Is it balanced? Yes, it's balanced. Ethanoic acid turns universal indicator paper blue. Ethanoic acid, it's an acid, so it turns universal indicator paper red, not blue. Ethanoic acid has a pH lower than pH 7. Yes, because it's acidic. So the answer is C, 1 and 4. Okay, about statement number 2, ethanoic acid reacts with carbonates to produce hydrogen gas. No, it's wrong. Carbon dioxide gas is produced, not hydrogen gas. Okay. 39. What is the name of the ester? Ester is from alcohol and carboxylic acid. When carboxylic acid reacts with alcohol, ester and water are produced. Okay, now we have to give name for this ester compound. Remember, the name of the alkyl must be mentioned first. This is the alkyl. The alkyl is from alcohol. So this is propyl. This is from propanol. And the remaining is from carboxylic acid. It has 2 carbon atoms. So this is from ethanoic acid. For ester, we have to give suffix oid. So this is ethanoid. So the name for this ester is propyl ethanoid. The answer is C. 40. The last one, the structure of a polymer is shown. This one. There is glycosidic bond. Which type of polymer is shown and by which process is it formed? Actually, this is carbohydrate formed by condensation polymerization.